One. Today we are going to see about moving charges and magnetism, the second part, and some of the problems which will be explained in detail. We'll see that one in this session. You know. Okay, first problem here is two concentric circular coils. See, there are two coils, concentric circular coils, that is about thick coils, right? See, there are two coils A and B of radii. They are given 25 centimeter for the first coil, 15 centimeter for the second coil, and carries a current. First coil which carries a 10 ampere of current, second one is 15 ampere of current. And the first coil has 24 number of turns, second coil has 18 number of turns. They are mentioned as A and B. See, this one they are mentioned as A and B. The direction of the current are in opposite order. Now the direct current flow in this case, one is moving towards this direction clockwise, another one is moving in anti-clockwise direction. So that what happened here is current direction is opposite, so that the magnetic field at the center of each coil will be in opposite to the direction, so that the magnetic induction at the common center of the coil is. So what they are asking here is the magnetic field at the common center of the coil. See, in this case what I am going to mention here is, you just see about one coil, it carries a current. I just mentioned here, it carries a current 10 ampere of current. Another one more coil I just mentioned here, which carries a current of 50 ampere of current. See, in between this magnetic field produced at this center, and this is magnetic field or magnetic induction produced at this center. At the common center, you just see at the common center over here, what is the magnetic field which can be produced by these two coil which carries a current of 10 ampere and 15 ampere. See here, one is moving towards this direction, another one is moving towards this direction, clockwise and anti-clockwise direction, so that these two magnetic fields are opposite together. See, for example, already we know this one. In case of, I just mentioned as magnetic induction here is mu naught. See, number of turns already they are mentioned here, so that I just mentioned as mu naught Ni divided by 2R. So what are the things are varying? This is a common formula. What are the things are varying in this case? Magnetic induction is already varied. See, I just mentioned here for the first coil PA, and the number of turns has been varied, and the current also vary, and even radius also vary. Similarly, in this case, because of this one, I just mentioned here, dB here is mu naught N B I B and divided by 2 into RB. Now, what they are asking here in this case, what is the total magnetic induction at the common center? I just mentioned as B net is equal to, say this one, BB minus BA. Now, I just mentioned here BB minus BA. You just substitute the value for BB here is mu naught. Mu naught is the common one, so I just take this one common out, and mu naught into NB here, NB IB divided by 2 of RB. Similarly, here is this one NA IA divided by 2 of RE. Now substitute all the values over here. Now I just substitute this one mu naught into, see here, mu NB number of turns in the secondary coil, that is about, I just mentioned as 18, and the current flow in that coil here is 15 here, and divided by 2 into radius of the coil, how much they are mentioned here is 15 centimeter, 15 into 10 power minus 2 meter. Now next one, in this case again mu naught we have taken out. Number of turns in the primary coil here is 24 number of turns, and the current flow in this coil here is 10 ampere of current, and divided by 2 into, and radius here is what they are given, 25 centimeter, 25 into 10 power minus 2. Now this one, in this case, see here what I'm going to mention here is this one, 15 15 will be cancelled here. 18 divided by 2 here is 9. So what you are having here is mu naught into 9 into, here is 10 power minus 2. It is in denominator. Once it comes to the numerator, that is 10 power plus 2. 10 power plus 2 means that is 100. And here I just mentioned here, this one here is 12, and here 24. This one, once if it is comes to the numerator, in this case that is about 1000 divided by 25, and even you are having 12. Now I just mentioned here, this is for 40 times, right? 40 times. Now 40 into this one mu naught, I just mentioned here, mu naught into 900 minus 40 into 12 here is, what you are having here is 480. So what you are going to have here is 420 Tesla. So answer in this case 420 Tesla. in a wire of circular form. See, wire which is in a circular form has 4 ampere current, so I value is given, is following to a magnetic induction. B value is given, that is 1 micro Tesla. As it is center, the radius of the circle should be. Now this is simple one, you just work out the problem. I just give you the idea. See, till now we have seen about this one only. For this case, B is equal to, see here, mu naught I. See, what they have given here is circular form, the number of coils. They didn't mention here number of coils. So circular form, the wire, so that N here is 1, mu naught I divided by 2 into R. So see here, they have given I values and they have given a B value. B value here is, I just mentioned here, that is 1 into 10 power minus 6 Tesla. Mu naught value here is 4 pi into 10 power minus 7, and the current value what you have given here is 4 ampere, and divided by 2 into radius. That's what we are going to find. From this one, R is equal to, see, you just take this one everything over here, or else you just cancel over here. This is 2, that is 8 pi, that is, see, even you can cancel over here. This is 10 power minus 1. See, from this one, R is equal to 4 pi into 10 power minus 1 into 2 divided by, so you are having, you don't have anything over here, so you just simplify here. What you are going to have here is, you just simplify this one so that you can get the answer here is 2.5 meter. You just work out this one. Answer in this case 2.5 meter. Here is a wire of length L. L length of the wire carrying a current is I ampere, is bent in the form of a circle. See, a lengthy wire is bent in form of a circle. It's a magnetic moment. So capital M is about the magnetic moment. That's what they are asking here. See, for this one, you can go through this theoretical part of it. See here, a magnetic moment of the circular coil is given by magnetic moment here is M is equal to I into A. I is about the current, A is about area of cross section, N is about number of turns. Hence, in this case, the magnetic moment here is, this is about the formula. Let me tell you in this case. See here, now in this one, see, length of the wire I just mentioned here. This is about the simply length of the wire which carries a current here is I. Now this wire can be made into a form of a circle. I just mentioned here, it form of the circle which is having a radius here is R, and it carries a current here is I. Now and here, so that N here is, in this case, N is equal to 1. See, from this one I just mentioned the formula here. So M, magnetic moment M is equal to, N here is 1 I into E. Okay, now listen here. In this case, the length of the wire, length here is L, which can made into a circle, so that the length will be equal to the circumference of the circle. From this one I just mentioned here, length here will be equal to 2 pi r. So from here, R is equal to, radius of the circle here is L divided by 2 pi. Now next one, what is the area? Area of the circle I just mentioned here. In this case, area here is, already you know this one, area here is, area of the circle here is pi r square. Now pi into, already R value we found out here, just substitute the value. R here is L divided by 2 pi to the whole square. So what you are going to have here is pi into L square divided by 4 pi square. Now this pi and this one will be cancelled here. So what you are going to have here is L square divided by 4 pi. Now substitute this values to the equation. So magnetic moment I just mentioned here. Magnetic moment formula here is, what is the formula? Already I have mentioned here. M is equal to current into area. So N is equal to 1. So you just mention here. Current value here is, I just mentioned as I. Area what you got here is L square divided by 4 pi. So what you are getting, that answer here is M is equal to I L square divided by 4 pi. Now this one, see here, in this case, current value here is ampere and L here is length. So you are going to mention L is measured in meter, so meter square, ampere meter square. So answer here is I L square divided by 4 pi ampere meter square. Here is, See, two identical coils. Identical means both are similar coils, have a common center, and their planes are at right angles to each other and carrying equal currents. See, for that, let me tell you here. See, there are two coils I just mentioned in this case. One coil which is along this direction, for example, I just mentioned here, which is a common, and another one more coil you just see here. Two coils, I just mentioned this one, similar like this, right? Okay, now you just go through on this one. See here, two identical. Both are similar like this coil. Both are similar here. Have a common center. So this is having common center. See for this one common center in this case I just mentioned here. See this one. Both the coils are right angles together. So which is having common center here. And their planes are right angles to each other. So this one. See this is around. This one, this is horizontal plane, and this one in this case this is vertical plane. Vertical plane and horizontal planes are right angles to each other and carry equal current. So here both are having equal current. The magnitude of magnetic induction field at the center due to the coil is B. So what they have given here is, in this case already you know this one, the formula here is B is equal to, I just mentioned here, B is equal to mu naught N I divided by 2R. Right, both are similar in this case. So this one, for that I just mentioned here B1, say for example BA or B2 or even B2 you just mentioned here, similar like this you are going to have. See for this one, what they are asking here is resultant magnetic moment. See this one I just mentioned in this case, for resultant magnetic moment, one is about horizontal coil, so that resultant magnetic moment already they have given, that is Bi. One is about the vertical coil, that is about Bj. So net magnetic induction here is Bi plus Bj, because they have given the magnitude of magnetic induction here is B. Now net magnetic induction here is, if you want to go take only the magnitude in this case, this one this is about the product, you can understand this one from a mathematics. See from here, say suppose if you want to take this one, hope you remember here. So you just take this one I just mentioned here, you just put a modulus over here. See, square it, take a root, so that what you are going to have here is this formula, you are going to get this one. See from this one what you are going to have here is, that is square root of 2b square, take a root of this one, so answer in this case root 2b. Here is a wire of length is L is bent into a circular loop of radius R. Now, length of the wire L and bent into a radius R, circular loop, and carries a current here is I. The magnetic field at the center of the loop is B. Now, this one, see what they have given in this case, let me tell you here. You just consider a circular loop. This one I just mentioned here, a circular loop of radius here is what they have given. The radius here is capital R, and the length of the loop it made into a length here is L, and the current flow here is I. Now the magnetic induction, see here the magnetic induction for this one, they have what they have given here is B. Now the same material is bent into double loop, that means see here I just mentioned this one, it is made into two loops. Now and even it carries the same current here as I, but radius has been changed here. See this one, in this case there are, this is only one loop, here is two loops, so I just mentioned here for the radius in this case I just mentioned as R2 or even R dash, something like that. If both the loops carrying the same current in the same direction, then the magnetic induction at the center of the loop. Now first in this case I just mentioned here, in this one L is equal to L here is what I'm going to mention here is 2 pi into R and into N. See here is N equal to 1, only one loop. See from this one what I'm going to mention, what are the changes is going to happen in between this one and this one here is, only thing is N and the radius. So what I'm going to mention here is, from this one capital R will be equal to L divided by 2 pi N. See from this one, see L is not going to change, length is remains constant, and the 2 pi also the same. From here R is proportional to 1 by N. And the magnetic induction what we have given here is, magnetic induction I just mentioned here, B is equal to mu naught I divided by 2 into R, and depends on the number of turns I just mentioned as N. For the first one, number of turns here is 1, the second one number of turns here is 2. So only changes over here is N and R, and I current will be the same, already they have mentioned here. See the magnetic field, see already they have mentioned in this case I just mentioned here. See in this one, if the both the loops carries the same current, current is not going to change, so that current will be the same. So this is also constant. So only changes here is B is proportional to, I just mentioned here, B is proportional to N divided by R. Already you know this one. R value here is N divided by um, 1 by N again. So what you are going to have here is B is proportional to N square. Already this one we have seen in the last session, previous session problem only. We just go through on this one. So B is proportional to N square. For this one I just mentioned here, B1 by B2 equal to N1 square divided by N2 square. N1 here is 1, N2 here is 2 square. So what you are going to have, B1 divided by B2 is equal to 1 by 4, or even B2 is equal to, what you are going to have here is 4B1. Already B1 already they have given, B1 here is B. So what you are going to have here is 4 into B. So answer in this case will be. Problem here is, a circular coil is made up of a wire of length 2 meter. So it's made up of a 2 meter length wire. It's made into a circular coil which is having a radius here is 4 by 5 centimeter. And when a current of 1 ampere is passed through it in that coil, what is that magnetic moment? That's what we are going to find out, the magnetic moment in this case. First one, see the length of the wire I just mentioned here. Length here is L. L will be equal to the circumference of the circle 2 pi r into, see here, number of turns. If it is made into number of circular coil means that number have to mention here. If it is only 1 means n is equal to 1. See from this one, n is equal to L divided by 2 pi. Now this one L value already they have given. What is that L value here is? See 2 pi r, and L value here is 2 meter and whole divided by 2 pi into R value. What you have given here is 4 by pi centimeter. Centimeter you have to convert this one in meter. So I just mentioned is 10 power minus 2. Here is 2 and 2 will be cancelled here. Pi and pi will be cancelled here. See this one, in this case what I am going to mention here is 10 power minus 2 in a numerator it will become 10 power 2. 10 power 2 here is 100. 100 divided by 4 here is 25. So in this case n is equal to 25 number of turns. Now magnetic moment, already we have seen this one. See you can understand over here, magnetic moment here is M is equal to N I into A. Now this one N value already you know this one, 25 into current value they have given, that is 1 ampere. Area here is pi r square. Now I just mentioned here 25 into 1 into pi into r here is 4 by pi. So I just mentioned here 4 by pi into 10 power minus 2, and another one r here is 4 by pi into 10 power minus 2. Now this one in this case pi 1 pi and 1 pi will be cancelled here. 25 into, see here, this 25 into 4 what I mentioned here is 100. Now I just mentioned this one in this case 100 into 10 power minus 2. Again one more see here one more 4 is there and one more 10 power minus 2 is there, and the denominator what you are having here is 1 pi is there. Now this 100, this 10 power minus 2 will go, and this one 4 divided by 100 pi is the answer for this case. Is quite interesting and important one. This one we are going to find out the formula that we have done already previous questions. In this questions they are asking about formula of this one. Additional information they have given about omega. See here, first a ring of radius r is uniformly charged. See what they have given here is one important point. This is ring. Coil means number of turns will be there. This is ring means only one circle wire, right? Radius r is uniformly charged with a charge. They have given about the charge. Once they have given about the charge means what is the current, you can mention here current I is equal to this one. I here is charge by time. This is about current we can find out with the help of charge. Now next one what you have given here is, if the ring is rotated about its own axis with the angular frequency, they have given angular frequency omega. See from this one, velocity you can find out here, velocity v is equal to, see this one already we know this one, angular velocity here is v is equal to angular velocity or even angular frequency here is omega. The normal velocity or normal frequency nu is equal to r omega here. Now from this one B you can find out here. Then what they are asking here is magnetic induction. Magnetic induction formula already you know this one. B is equal to this one. B is equal to mu naught I divided by 2 into R. This is about a magnetic induction general formula here. See from this one they having given about I value. So from charge you can find out I value here. Now I just substitute in this case mu naught instead of I just mention as Q divided by T and whole divided by 2R. Now what is the relationship between the velocity and time here is now this one velocity is equal to distance by time or even displacement by time here. Now I just mention here in this case distance by time here is which is moving in a circular ring. So distance in this case I just mentioned here 2 pi r, that is nothing but the length of the wire, right? This one 2 pi r divided by time here is t. Now in this case V is equal to already you know this one V here is I just mentioned as r omega, that one will be equal to 2 pi r divided by t. In this case r and r will be cancelled here. For this one instead of t what you can mention here is t is equal to 2 pi divided by omega. Now you can utilize this value over here. Now I just mentioned this one mu naught, see here mu naught q divided by 2t into r. Now I just mentioned in this case instead of t I just mentioned as mu q divided by 2 into t value here is 2 pi by omega here into r is there. Now from this one omega will come in numerator, so mu naught and this one here is q into omega and divided by 2 into 2 pi here is 4 pi into r. So this one what they have given the answer in this case here is B is equal to B here is this is the answer. Whereas two circular coil are made from a uniform copper wire. See here, two circular coil in the sense a number of turns will be there are made up of a copper wire. Radii of the circular coil is in the ratio of 3:4. That means R1 by R2 here is 3 by 4 and the number of turns in the ratio here is N1 by N2 what they have given 3:5. Then they are connected in series. This one important things you have to remember. Once if it is connected in series, what you mean by current over here? Here see in both the coils are connected in series. In this case current will be the same and only the potential V will be vary. Am I clear? V will be differ here and current will be same. Now in this case they have given the two statements. Statement 1 is a ratio between the magnetic field induction, that is B1 by B2 here is 4:5, and statement B here is a ratio between the magnetic moment M1 by M2 what they have given in this case 16:5. This one we are going to find out. The first thing about we are going to find out what is the ratio between B1 and B2. Before going to that we just mention here R1 divided by R2 what they have given here is 3 by 4 and another data what they have given here is n1 divided by n2 what they have given the value here is 3 by 5 and what they are asking in this case the first one here is b1 divided by b2 divided by b2 already you know this one. Before going to that I just mentioned here b is equal to this one you can understand here magnetic induction b is equal to mu naught n I divided by 2 into r. See in this one mu I and 2 all these three are constant, so B is proportional to n divided by r. So B1 in this case B1 here is n1 by r1, B2 here is n2 by r2. See in this one B1 by B2 here is n1 by r1, here is whole divided by n2. So what you are going to have here is r2 divided by n2 here. So n1 by n2, see n1 by n2 into r2 by r1. Now I just mentioned here n1 by n2 already they have given. What they have given here is 3 by 5. Now I just mentioned as 3 divided by 5 and r1 by r2 they have given 3 by 4. But what you are going to mention R2 by R1, so I just mentioned as 4 by 3. So in this case 3 and 3 will be cancelled. So what you are getting that answer here is 4 divided by 5. So B1 divided by B2 is equal to 4 by 5. So here is what they have given here is B1 divided by B2, that one will be equal to 4 by 5. So the statement A is correct. Now we are going to concentrate about the second statement, that is magnetic moment. Now this one magnetic moment I just mentioned here, M is equal to, what is that value here? M here is N into I into A. Now in this one current will be the same, area will be vary. Area in this case I just mentioned here, N I into area. This is circular coil, so M pi r square, this one. So from this pi I will be differ, n and r will be the same, so I just mentioned here. So in this one, in this case, m is proportional to, what you are going to mention here is n r square. M1 in this case, n1 r1. See here m1. So what they are asking here is m1 by m2. I just mentioned here, that is n1 r1 square divided by n2 r2 square. Now n1 by n2, already you know this one, n1 by n2, what they have given here is 3 by 5. Now I just mentioned here, and r1 by r2, r1 by r2, what they have given here is 3 by 4, 3 by 4 whole square. Now I just mentioned here 3 by 5 into this one here is 9 by 16. So what you are going to have here is this one, 9 into 3 is 27, and 16 into 5 here is 80. Now this one m1 by m2 will be equal to 27 by 8, but what they have given here is 16 by 5. So this statement here is wrong, so only A only correct. So answer in this case here is, this is important, even previously asked questions. This is somehow related to the chapter atom also. We just concentrate here. A charge here is q and mass here is m, is rotating in a circular orbit of radius r. Now let me show you here. If the charge particle, this is about the charge particle moving in a circular orbit which is having a radius is r, charge is q, and mass here is m. Now and moving with velocity speed, what they have given here is, see I just mentioned in this case, velocity here is which is moving with velocity v. So the charge particle moving with velocity and mass here is m. What they are asking, the ratio of between, see this one we used to mention as m, here they are given as mu, and the angular momentum here is L. See for this one already we know this one, m is equal to, so or even m or mu, I just mentioned as mu here, mu is equal to, what you are having here is NIA, and already you know this one, this is only one orbit, so n is equal to 1. So n here is 1, and the current here is, this is about the charge over a time. Now time how you can find out here is, velocity is equal to this one, distance by time here. From this one, time here is distance by velocity, distance here is, this is moving in a circular orbit, so I just mentioned here 2 pi r divided by v. Now from this one you can mention here q divided by time, instead of t I just mentioned as 2 pi r into v. This is about the current here. And area I just mentioned here, area is equal to pi r square. Now substitute this value, then find out what is mu here. Mu is equal to, I just mentioned this one, mu is equal to uh, mu here is 1 into current value qv divided by 2 pi r into area here is pi r square. Now you just substitute this value here. See this pi and pi will be cancelled here. 1 r and 1 r will be cancelled here. So this one what you are going to have here is qv, and 1 r is there, divided by divided by 2. Now this one, from here what you are going to have here is mu value, that is 2v qv r divided by 2. And next one, yeah, you are going to find out what is angular momentum. L is equal to, angular momentum here is I omega. I here is a moment of inertia when a particle moving in a circular orbit here is m r square. Omega here is angular momentum, so we can mention here v is equal to r omega. See for this one I just mentioned in this case, v is equal to r omega means from here omega is equal to, from here omega is equal to v divided by r. Now you just mention here v divided by r, so 1 r will be cancelled here, so what you are having here is m r into v, that is about L. So what they are asking in this case, so this one mu divided by L, that's what they are asking here. Mu value here is, I just mentioned here, qvr divided by 2, and whole divided by L, what you are having here is m r into v. Now for this one, see I just mentioned here qv r divided by 2 m r into v. So VR will be cancelled here. So what you are going to have here is Q divided by M. Remember here, this is about mu to L, ratio between magnetic moment to that angular moment. So answer in this case here is one. This one they are frequently asked in the question paper like a NEET and EAMCET problem. You just go through, you just concentrate little. See equivalent current I. See I current is flows into two segment of the circular loop. See one segment is from A to B along clockwise direction. Again from A to B along anti-clockwise direction. There are two segments. This is the first segment and second segment. The equal amount of the current, but the direction here is opposite to the direction. And in the figure as shown in the figure, the radius of the loop what they are given, the radius here is a. See I just mentioned here in this case radius what they have given here is radius of the loop here is a here, right? Okay, now next one. So what they are asking in this case, the magnetic field at the center of the loop is. Now for this one already we know this one. In the last previous first session we have discussed about this one. I just give the link at the end of the slide. You just go through on this one. See here, in this case, if the wire is bent in the circular form, the formula here is, you can confirm this one. See B equal to mu naught I by 4 pi R. See here radius what they are given here is A, and here they are given as R is the radius and theta is the angle between the two segments. See here is angle here is 2 theta. So remember this one, mu naught I by 4 pi R. Remember this one. In this previous problem, magnetic induction under mu naught I divided by 2 R, pi won't be there and 1 N will be there. Here is instead of this one mu naught I by 4 pi R. Remember this formula here. Now in this case, so A will be given in this case. Now I just mentioned here. So so this one here is angle. In this case this is theta here, and another one more. For example, this one I just mentioned here, this one angle here is total is 2 pi minus theta. This is the angle between the segment A to B in clockwise direction, and this is anti-clockwise direction. This is the segment between A and B. For this one, the net magnetic, see here, the what they are asking here is the net magnetic field. I just mentioned here, that one here is B2 minus B1. First we just mentioned what is B2 here. See B2 in this case I just mentioned here. See this one, and this one I just mentioned as B2, the magnetic field produced by the segment when the current flow in the clockwise direction, and B1 here is the current flow in the anti-clockwise direction, the segment of A to B. See from this one I just mentioned here, B2 is equal to mu naught. See remember this one, mu naught I divided by 4 pi R here is A, and here angle here is 2 pi minus theta. So this one angle here is theta. I just mentioned here. This is not here. This is theta here. 2 pi minus theta. And the next one B1 is a similar one, mu naught I divided by 4 pi A, and the angle here is theta. So what you are going to find out, B net is equal to, B net here is the common one I just mentioned here, mu naught I divided by 4 pi A. I just take it out, and the remaining what you are going to have here is 2 pi minus theta. So this one, and a minus of, so minus of this one is theta here, and minus of this one theta. So what you are going to have here is 2 is the common one. I just take this one out, mu naught I divided by 4 pi A. This one here is 2 pi minus theta, that is minus 2 theta. So 2 I will take it out. So what you are going to have here is pi minus theta here. This 2 will be cancelled here. Only 2 is there. So answer in this case, mu naught I divided by 2 pi A into pi minus theta. This one remember here, this is most important. And even this one assertion and reasoning also, they are frequently asking such type of questions. For this one, answer in this case, this one here is mu naught I by 2 pi A into pi minus theta. Interesting problem, and important also. You just go through on this one. Two wires A and B are length. So two wire which is having a different length. One is 40 centimeter, another one is 30 centimeter. Now this one A is bent into a circle. Now one wire is made into a circle, and see I just mentioned here. For example, one wire is made into a circle of radius here is R, and B is made up of an arc. This one I just mentioned here. One is made up of an arc. Now a current I1 is passed through A. See this one in this case I just mentioned here. Current in this case which is passing through here is I'm sorry. this one, a current passing through here is I1, and the next one here is a current I through passing through here is I just mentioned as I2 here. Now to have the same magnetic induction, see here in both the case, to have a same magnetic induction, how much current ratio should be there. So in this case what I'm going to mention here is you should have a same magnetic induction. For this one I just mentioned here, for this what you are going to have, the length in this case I just mentioned here, length here is 40 in this case 40 centimeter, here the length in this case here is 30 centimeter. Now for this one, the magnetic induction in this case I just mentioned as B1 is equal to, hope you remember the previous one I have displayed here, mu naught, see here mu naught I1 divided by 4 pi r into theta 1. So this is about theta 1 is the angle. See, this is in a circular one. So the total angle here is 2 pi r. Now for this one I just mentioned here, and even the length here is 40 centimeters. For this one I just mentioned here, length is equal to 2 pi r. Here theta value here is theta is equal to 2 pi. See, from this one length value already they are given, that is 40 is equal to 2 pi into r. From here 2 pi is equal to 40 divided by r. Remember this one, see 40 divided by r, right? Now listen here, see I just mentioned this one little neatly. See here is 40 divided by r from this steps. Now instead of theta, instead of theta you are going to mention as 2 pi. Here is B1 is equal to mu naught I1 divided by 4 pi r. Here theta, instead of theta I just mention as 40 divided by r. Now in this case, see here, this one I just mentioned as, this is about arc over here. For this one I just mentioned over like this, so that you can understand better. Here this is about the radius. C in arc having a radius here is r, already they are mentioned. Now in this case it's make an angle, I just mentioned that this is theta 2 here. So the length of the arc L is equal to, hope you remember this one, this one here is L is equal to r into theta. You can understand over here. For example, if you are considering about, for better understanding I just mentioned here, if sine theta is equal to, sine theta here is opposite side by, for example if you consider this is something like a this is something like a right angle triangle. If you consider this one, sine theta here is opposite side by hypotenuse. Hypotenuse here is this is sine theta. Hypotenuse I just mentioned as radius here. Opposite side I just mentioned over here. And sine theta, if angle is very small, sine theta equal to theta. So opposite side, that is about the length here is r into theta. Similar concept over here. You can find out over here. Length here is what you are going to have here is 30. 30 is equal to r into theta. From this one, you can mention here. Same here I just mentioned here. B2 is equal to mu naught I2 and divided by 4 pi r into theta 2 here. Instead of theta 2, what I'm going to mention here is, see from this one you can get the theta values here. Theta values I just mentioned here. Theta is equal to 30 divided by r. So mu naught I2 divided by 4 pi r into theta 2. Instead of theta 2, what you are going to mention here is 30 divided by r. This is B2. And you can observe over here, it should have a same magnetic induction. That means I just mentioned here in this case B1 will be equal to B2. Now substitute both the values here, mu naught I1 divided by 4 pi r into 40 divided by r. Similarly here is what you are going to have here is mu naught I2 divided by 4 pi r into 30 divided by r. Now this one mu naught will be cancelled here, and this one 4 pi r will be cancelled here. Additional this also will be cancelled here. See from this one what they are asking here is I1 divided by I2 here is 30 divided by 40, that is 3:4. So answer in this case here is 3:4. Important, see here the helium nucleus, already they have mentioned this is helium nucleus. Helium means there are two electrons will be there in the outermost orbit and makes a full rotation in a circle of radius c. See here, this is about the circle I just mentioned here. Circle of radius here is 0.8 meter. I just mentioned here 0.8 meter. So it will cover that the charge particle helium nucleus. It will take a full rotation in 2 seconds. So the magnetic induction at the center here is, see this one helium nucleus, how you can mention here is, I just mentioned here 2he4. Here this one which will be similar to that atom will be depicted like this. It will be depicted like a ZXA, where Z is about the atomic number. Atomic number is nothing but number of protons and number of electrons. So this one it will be mentioned like number of protons and number of electrons. And A here is number of protons plus neutron. This one proton plus neutron here. And hope you know this one A minus Z here is number of neutrons. So this one is number of neutrons. From this one, how many electrons is there? There are 2 electrons. For this one, magnetic induction, already you know this one, B is equal to mu naught I divided by 2 into R. And N it can be mentioned based on, that is about the coil, you can mention here N. This is only the nucleus, that is helium nucleus. So that what I am going to mention here is, instead of this one I just mention here Q divided by T. So there are 2 charges over here. Now I just substitute here B is equal to mu naught, instead of I just mention as Q divided by 2TR. Now I just mentioned in this case mu naught into, there are 2 charges over there, so 2q, even you can mention as 2q here, that is a charge of the electron here is 1.6 into 10 power minus 19 coulomb. And there are 2 charges because this is the helium nucleus, so 2 charges which is having a charge. So I just mentioned here into 2 into time, it will take a 2 seconds, so I just mentioned as 2. And your radius here is 0.8. See, for this one 2 and zero point 0.8 you can cancel here for 1.6, and this one, this 2 and this 2 will be cancelled here. So what you are going to have here is mu naught into 10 power minus 19. So answer here is little important. You just go through on this one. A current carrying circular coil of radius they have given, that is 11 centimeter here. So you have to convert this one in meter, 11 into 10 power minus 2, which is placed in its plane of meridian, magnetic meridian. See here, for this one you can understand here, magnetic meridian is about this one. One is about for this already they have given. See here, this is about the horizontal component. You just see here magnetic meridian. What they are asking, the resultant magnetic induction at the center. From the center of the coil, what is the magnetic induction? See, magnetic induction you are going to find out. One is about the horizontal component, one is about the vertical component, and the current flow they have given here. See, for that you can understand here. Let me mention this one. For in case of this one vertical component, I just mentioned here B. For example, I just mentioned as B1 is equal to, already you know this one, magnetic induction here is mu naught I divided by 2R. Now this one, in this case, I just substitute the value mu naught here is 4 pi. 4 into pi value I just mentioned here 22 divided by 7, or even 3.14, and the current value already they have given, that is 7 divided by 2 into R value they have given as 11 centimeter, 11 into 10 power minus 2 meter. Now for this one, see 11 into 2, that is 22, you can cancel over here, and this one 7 and the 7 will be cancelled here. So what you are going to have here is 4 into 10 power, this one here 4 into 10 power minus 2, it will become plus 2 here. And even see here, this is 4 pi into mu naught value here is 4 pi into 10 power minus 7. I have forget over here, so you just mention this one also, 4 pi into 10 power minus 7 here. So this one will be cancelled. What you are going to have here is 4 into 10 power minus 5 is there. See, for this one, see, you can understand over here for this what you mean by gas to Tesla. What you are getting here is all the answer which will be in Tesla here. Now you have to convert this one in gas, because they have given the value in gas. See, I just mentioned in this case, this one here is one, I just mentioned here, one gas will be equal to 10 power minus 4 Tesla. Now instead of Tesla, what I'm going to mention here is, see this one, see from here what I'm going to mention here is instead of Tesla, 1 Tesla will be equal to, or even 1 gas here is 10 power minus 4. See this one, simply I just mentioned here, 1 Tesla here is 1 divided by 10 power minus 4 gas, this one, or even minus 4 gas, or even 10 power 4 gas, or even 10,000 gas, 1 Tesla will be equal to 10,000 gas. See, according to this, you just arrange over here. This one what I'm going to mention here is 4 into 10 power minus 1 into 10 power minus 4 Tesla. 10 power minus 4 Tesla is nothing but gas. So what I'm going to mention here is 0.4 gas. That is about B1. And the next one, B2, already they have given that value, that is about the horizontal component, already they have given, that is about zero point 0.4 gas. See, from this one you are going to find out a B net. The total magnetic induction at the center here is B1 square plus B2 square here. So from this one, what you are going to mention here is, I just mentioned as both the values are same over here, that is zero point 0.4, zero point 0.4, that is 2 times of 0.4 square here. So into, take a root of this one. So what you are going to have here is root 2 into 0.4 gas. So that one I just mentioned here, 4 gas here. Now this one from here, what you are going to have here is mm, zero point 0.4 gas. See, all the answers are in a Tesla. Again, you just mentioned here 1 gas is equal to, again you just mentioned here 0.4 into 1 gas is nothing but 10 power minus 4 Tesla. Now this one, I am sorry, I just mentioned here. Now from this one I just mentioned here in this case, see here is this one I just mentioned as zero point 0.4, here is I just mentioned as uh, 4 into, again this one root 2 is there, 4 into root 2 into this one zero point 0.4 I just mentioned as 4, so that you are having one more is there, that is 10 power minus 5 Tesla. So answer in this case, problem will be discussed in the next session. You just go through on this one. The link will be given over here. You just go through on this.